So as you can see here, we have a data frame with 5 rows and 10 columns, and Q1 is a Boolean column with trues and falses and missings as well. So this is an integer that is, as you know, in R it's stored as a double, and this is a double with its values and its missing values, and then complex numbers with missing values, and then also a char character with a missing values here, and we also have a final one with a missing value here, but with infinite and not a number as well. There are not missing values. So how do we work with complete? Well, the complete cases method, it receives a data frame and it checks if there is any missing. It's not a complete case. If it must have all data without missing. And in my data set, in this data frame, only two rows have no missings. As you can see here, this is an infinite. It's not a missing, so it's being considered as a no missing value. And if you get as in this and assign to a new df, so you can play with the new df filtered. So it's actually has deleted. It hasn't deleted that actually because the leadership still has all the data, but it made a copy to a new df, and the new df hasn't got any missing now. But we can also get all the missing values if we put a not here or exclamation sign, because this way we're able to have a look at the missing cases only. The VIM package, it has a function called aggr or aggr, and this function is really helpful because it actually draws a pattern, and it says, well, basically this is not an order actually on my data set. It reorders everything. It's basically saying 2 cases has no missing whatsoever. 1 case has this pattern, missing on the Q2 and Q3, and a Q5 has missing as well. So if there was more cases with this pattern, it would have a number 2 here or 3. And how many missings do I have? No missings on manager, no missings on data, on date, no missings on gender, no missings on age. 2 missings on Q1, 2 missings on Q2, and Q4 has 1 missing only. Function matrix plot from the same library is quite cool because it actually reorders all the cases, grouping all the missing cases together, making a blood mark. So let's suppose you have a data frame full of missing cases. If it groups all the missing cases together, putting the missing cases of the same column together, you can see like a blood mark on your missing on your data frame, and you can see that maybe there is a problem in some cases because they are correlated or something. A cool function is margin plot. Basically, imagine age here with all information and it has no missing, but Q1 has some missing. What would happen if I drop the none for the entire row? How would that change age? Basically, guys, this is the Q1 and this is age. And in red, I get all the normal cases of age, including those ones with missing value from the Q1. But if I go there and drop nuns and remove all the nuns, so get complete cases on these 2 columns, then if I'm dropping those 2 lines, the actual age distribution will change a lot, as you can see. Obviously, it's only a few data points here, but in any case, margin plot is telling me what would happen with another variable if you drop cases from one variable that has missed. So this is really powerful if you can actually drop, if you're not influentiating the other column. What else can we do to analyze it? So let's suppose this is lead data set. Basically, it has some missings. Cool. So let's do a map where we say we're doing a transformation here with this function, just basically transforming any data that has a none is going to be marked as a 1. And if it has a data, it's going to be marked as a 0. Why? Because then I'm going to apply simply the correlation function. And what am I going to do here with the correlation? Basically, I'm applying a transformation here, summing by columns. and then I'm doing the correlation. So I'm doing correlation of the missing values. How many missing values appear in dreams and the non-D? How many appears on dream and the sleep? So I'm actually doing a correlation of the missing cases to see if there is any data like this one. Seems that when you have non-D, you get a dream. If you want to read what non-D is, you can go to the reference and see what this study was about. But this is basically saying that there is a high correlation. When there is a missing on dream, there will be a missing on non-D. With na.omit, we get the same idea as the complete cases, but instead of returning a true and false to filter, it actually returns a data frame. So here is the data frame before, and this is the data frame after. So basically getting only the two. So with final complete cases, omit, and some visualization. But what can we do with imputation? Can we change the values for another value? Yeah, there are a few things you can do that will help a lot on your transform with it, but will depend on the type of the data. So we're going to do a transformation for Boolean first. So this is how we find if it is a NA. So we have the vector here, false, false, true, false, false, true. So for column 1, basically I'm identifying which columns are the ones with missings. Cool. So for the ones with missings, because it's a Boolean, this case I'm basically putting a false because it makes sense for me. Maybe you want to put a true. So basically what you can do, you can just input a false or a true for Boolean. Again, will depend on your case. For Q2, that is a numeric one, I have few options I can do. So the first option is inputting 0. So I basically get the Q2, filter down by the cases that I want to put it. And as you can see here, after running, there is no missing anymore. If we look to the age column, we have the one NA here. And let's suppose we think this NA is an outlier and we want to remove it with the maximum value. So basically, how do I get the maximum? Well, I get the maximum like this. Oh no, it returns an A, obviously, because R has this funny behavior of counting the NAs by default and then returning NAs. That makes not much sense, but anyways. The way of solving this is basically putting na.rm equals to true, so it actually doesn't take the NA into account. And then it removes 43.3. And what we can do with that, basically we can return maximum and apply it the leadership age. And here it comes. We got the result here. Column 3 has NAs. And I don't want to put a 0 because we have done already, and I don't want to put the maximum. I could put the minimum as well, but now I'm going to put the mean. I could put the median if I want. But how do I get the mean? Oh, I get the mean like this. Oh no, I don't get the mean like this. I get the mean with the na.rm. And then I apply the mean for those cases that has an A. So here are the mean applied. So the average here. Just to show that I can do the same with the median for the Q4, the complex number, I can calculate the median instead. And I then apply for Q4. Oh my gosh, it doesn't apply. Because I forgot to put the na.rm here. Very careful. For the character column, we have a couple of NAs here, but they are text. So what can we do? Well, guys, maybe you can find the most common case that happens here, and then you replace by that, or we can replace with the empty text. Those are a couple of strategies, but basically there you go and replace by something. Well, you can study on your own the multiple imputation with my Samelli and my tools. But this is a good start of how to analyze the data, how to get rid of the incomplete cases and omit the nones, or how to do it with simple imputation. Thank you very much. That was Manuel Gadi, data cleaning with R.